Okay, so we've now assumed that Ri, the relative price, is distributed normally, and P is also distributed normally. Well, if that's the case, then since Pi is equal to Ri plus P, how do I see that? Well, Pi is equal, well, let me just actually write this. Ri is equal to Pi minus P. All right, so Pi is equal to Ri plus P, right? So since we've assumed that Ri is distributed normally, and we have assumed that P is distributed normally, the sum of two random variables is two normally distributed random variables is also normally distributed. Moreover, and we can actually see it down here. Moreover, since we've assumed that Ri and P are independent, we can actually just sum their two variances to get the variance of Pi. Okay. So, what is this equation here? This is an equation that I'm not going to derive, but it's just a nice property of normal random variables, which is the conditional distribution of a normal random variable conditional on, let me say it this way. If you have a multivariate normal distribution, then the conditional distribution in one of the dimensions is just a linear function of the variable you're conditioning on. So, like for instance, if I have, well, let's just say what it says here, and it is kind of intuitive. So suppose that I tell you what PI is, which is what the knowledge the firms are going to get. They're trying to figure out what's the best guess they can do about what Ri is, the relative price. It's just going to be, and yet of course Ri and Pi, they're distributed jointly normal. So the best guess you're going to be able to do about Ri conditional on Pi is just the overall expectation, the unconditional expectation of Ri, which happens to be 0, plus the difference between Pi and the expectation of Pi, so sort of the deviation of Pi from what you expected it to be, times some scalar. Okay, this is just some number. And what is the number? It's the covariance of Ri and Pi divided by the variance of Pi. Okay, so this isn't something I'm deriving. You can find it online, the derivation that if you have a multivariate normal distribution, then the conditional distribution is linear. But you can kind of see how this works too. So suppose that Ri and Pi are very correlated. Then it means that if I observe a high Pi relative to the expectation of Pi, then I should also observe a high Ri, since the two variables are correlated. So that's that. Okay. And then we also need to have the covariance between Ri and Pi. Why is that? Because we want to figure out what this guy is. This is the object that the firm is trying to estimate. So here we're arguing that that E of Pi is equal to E of P, right? The expectation of Pi is just going to be the expectation of P. All right. Here's the variance of Pi. Well, we've argued that that's just the variance of P plus the variance of R. Expectation of Ri, well, that's 0, right? The expected deviation of your price from the average price level is 0. So what's the last thing we need to figure out? It's what is this covariance between Ri and Pi. So let's write it down here. Okay. So that's the covariance of Ri and P plus Ri. I guess you can't see my pencil animation. Right, so Pi is equal to P plus Ri. So it's the covariance of Ri and P plus Ri. Well, that's just the covariance of Ri and P plus the covariance of Ri and Ri. Well, we've already assumed that the covariance of Ri and P is 0, right? We've assumed those two things are independent. That's on the last slide. So we end up with this covariance just equaling the variance of R. That's what we get here. The covariance of pi and ri is just the variance of r. So now we've got all the parts, okay? So we know that this is 0 because on average, you don't the deviations of the relative price from the average price level, or deviations of your price from the average price level are 0. We know that expectation of pi is equal to expectation of p. We know that the variance of pi is equal to variance of p plus the variance of r. And then finally, we know that the covariance of ri and pi is just the variance of r. Putting that all together, we end up with this expression here. Okay, so what is the best that a firm can do, conditional on pi, about its guess of ri? It's just going to be the pi minus the expected average price level. The firm doesn't observe this, but they have an expectation over it. Okay, scaled by the variance of the relative price divided by the variance of the relative price plus the variance of the average price level. Okay, all things that the firm knows. Okay, so what's the intuition here? I'll do this one, then I'll take a break. The intuition is that that when pi is higher, then my expected relative price is higher. That makes sense, right? I mean, all else equal, if I don't know what the average price level is, when I observe that my price is higher, well, I guess I would guess that my relative price is higher. But how much do I update my expectation? It depends upon this this term here. Okay, so this is like the strength of the signal. What this says is, if we expect that this thing here is very small, so suppose that the price level, the average price level never changes. You know, it's just always kind of the same. If I see a high pi, well, since the price level is always about the same, if I observe a high pi, well, that's probably my relative price. Okay, so when this thing is small, this term here is close to 1, and it means that I'm going to react a lot to changes in my own price level that I observe. Okay, on the other hand, suppose that this thing here, the average price level, is just jumping around. It's always something crazy. It's always really different from day to day. Well, then if I observe that my price isn't what I expected it to be, well, then there's very little information in that. I guess it's probably just the average price level jumping around. So that's kind of the intuition. So why do you say this is the strength of the signal? Pi here is the signal. You know, if the variance of this average price level is very high, then there's very little information in my signal that I can use to extract information about the average the relative price.